Hello, welcome to ACE Manager. Bottom line focus, ACE 26. Understanding direct material cost. My last three podcasts were three true stories on the concept of contribution, each having impacted the fortunes of the concerned organizations very significantly. In the first of the three stories on turnaround, it was purely activity level that made all the difference. A plant which was operating at 65,000 pistons per month, its break-even level started producing 110,000 pistons per month, had a significant gain, and the organization shared a part of its gain with the workmen in the form of group incentive, and the plant never looked back. Here the key word is the activity level. In the second story on product pricing, we have seen how increase in raw material prices promptly did not result in revision of product prices and caused huge losses to the organization. In the third story, relating to an integrated steel plant, we had seen how drop in market price for the finished product by 2,000 rupees per ton made exports unviable once we moved from overall contribution averaging both sales realization and energy cost per ton to specific assumptions like GAIL gas for domestic production and Petronet gas for export markets. I would like to extend the same concept to two more true stories which made a lot of sense to the concerned organizations. You need to go back to my turnaround story to recollect the piston manufacturing process once. If you are able to visualize the process as I am explaining, you will be able to enjoy these stories better. We said the product consisted of aluminum alloy made into castings in foundry and machining in the series of machining operations in the machine shop. These castings made in the foundry were also known as piston blanks. There used to be two broad categories of pistons known as ring carrier pistons and non-ring carrier pistons. Ring carrier pistons carried a much higher price in the market since they had much longer life and with minimal wear and tear. While the pistons were made of aluminum alloy, ring carrier pistons carried an extra ring made of nickel at the neck level of the piston, known as groove insert. Because of its material of construction, which was nickel, groove insert was very expensive and its wastage should be minimal. Now, I shall tell you about two specific situations in the production process where we spotted need for better monitoring and control with reference to ring carrier pistons, which were also called RC pistons. In the production of blanks in the foundry for RC pistons, the groove insert is placed in the die in an appropriate position and molten metal is poured. Since each RC piston blank carries one groove insert, if 10,000 blanks were produced, equal number of groove inserts should be consumed. But when we looked at the foundry records, we noticed groove insert consumption was erratic and much higher than the blanks produced during the corresponding period. While the production manager justified higher consumption of groove inserts, quoting some destructive tests and all, on the instance of the head of the plant, an inspection of foundry furnace and surrounding areas was conducted. It revealed large number of groove inserts lying in the trenches of the shop floor as scrap. Basically, there was no accountability for the number of groove inserts drawn by each worker for his production. Immediately, additional staff was placed in the foundry stores to issue groove inserts to each worker on record, and he was to return unused groove inserts, accounting for the number of blanks cast by him. This automatically brought down the consumption of groove inserts. Scrapped groove inserts found in the trenches were an accumulation of such wastage over a few years since the inception of the plant and were worth millions of rupees. Of course, nothing could be done about past losses. The second instance also related to RC pistons. Fully machined pistons are subject to quality checks, and rejection at final inspection can be as high as 20%. Scrapped pistons are put back in the foundry furnace for remelting, while aluminum alloy can be retrieved except for some melt loss. The groove insert, which is made of nickel, could not be reused. Thus, scrapping one RC piston was equivalent to scrapping 100 non-RC pistons. Immediately, we introduced separate statistical report for RC pistons to monitor their consumption of groove inserts. These two initiatives meant significant improvement in contribution with a corresponding reduction in the direct material cost. Trust you are appreciating the concept much better with these examples. Thank you for your attention.